All right, everybody, on to part 2 now of the 12.4 homework. So part 1 dealt entirely with angle measures that are formed when you've got tangents or secants or one of each intersecting at various parts within the circle. 12.4 part 2 deals with the same setup here with tangents or secants or one of each intersecting inside, outside, or on the circle. But in part 2, we're dealing with segment lengths. We're not talking about angle or arc measures here, so we really shouldn't see any degree signs within this section. So what's going on here in number 1? We're supposed to solve for x. And what we have here are two chords that are intersecting inside the circle. So that's really the important thing to recognize at the beginning here, guys, is where your point of intersection is, and this is where they're inside. And in the theorem in 12.4, part 2 notes that deals with this, it says that when two chords intersect inside of a circle, the products of each individual chord's pieces are going to be equal to each other. So if we take a look at this chord that I'm going to do here in purple, this chord is broken up into two pieces. We have an X right here and a 10. So what we're going to do is multiply those two pieces together, 10 times X. And that product right there is going to be equal to the product of the two pieces of the other chord. So the other chord I'm going to do in blue. It starts here, goes through that point in the middle, and ends right here. And the two pieces of that chord have lengths of 14 and 15, so we're going to multiply the 14 and 15 together. Okay, so let's clean up this right side here. There's not a whole lot we can do. The 14 times 15, I am pretty darn sure, is going to get us 210. Equals obviously stays in the middle, and the left side isn't going to change at all, guys. The 10 times x is just going to get us a 10x. The only thing we need to do here to solve for x is to divide both sides by 10, and lickety-split here, we're going to get x is equal to 21. And that is what we were looking for in this answer here. I hate to tell you guys to assume too much from the diagram, but if you kind of look at the whole thing, it really looks to me here like this 10 is the smallest out of the four pieces. And sure enough, 10 is smaller than 14 or 15 or the 21 that we just came up with. Now likewise, this piece right down here, the one that was labeled X, looks like it's the longest out of the four pieces, and 21 is bigger than 14 or 15 or 10. So that one chord that was in purple there contained both the shortest piece, 10, and the longest piece of 21. And the one in blue there had the 14 and the 15, which were the two in the middle. Okay, so that's number 1. 2, 3, and 4 are pretty similar here. Let's go to number 5. And what's going on here? We have ourselves a small tangent segment over here on the left with a length of 15, and then a secant segment over here on the right. And to get a little bit of vocab down, what we have right here, that I'm kind of covering right there, that 9 is called the exterior secant segment. And what we have here inside the circle, as you might guess, is called the interior secant segment. But an interior secant segment goes by another name. That's also a chord, everybody, which we've been talking about all chapter long here, a line segment whose endpoints are both located on a circle. And what's going on here, unlike problem number 1, is that our point of intersection is located outside of the circle. This point right here is outside of the circle, unlike in problem number 1, where the point of intersection was located inside. And that means it's a whole new theorem and a whole new idea. So the phrase that I wrote down in our notes, and if you missed it, we're going to go ahead and write it down right here as well, in a problem like this, is that we are going to do the outside portion of your segment is going to get multiplied by the whole thing. And if you can do that on both of the line segments that you're dealing with, those two products are always going to be equal to each other. So we need to remember outside portion times whole thing. So let's take a look. I'm going to erase all the doodling that I did within that. And I want to take a look first, everybody, at this secant segment right over here. And we're going to try to set up this expression right here, outside portion times the whole thing. So let's look at that segment in yellow, and first let's ask ourselves, how long is the outside portion of that yellow secant segment? How long is it outside of the circle? Well, that is this little piece right here, which has a length of 9. So we start with that. And now we're going to multiply the outside portion times the entire yellow segment. And this is something that people get wrong all the time. The entire yellow segment, everybody, let me switch colors on you here. The entire yellow segment goes from this point right here to this point all the way down. So it includes both the 9 that's outside and the X that's inside. So we've got to put the outer and the inner portion together. Now, a lot of people can understand that, but they still goof up how we express the total of that. They put the 9 and the X together and they make 9X. That's incorrect, everybody, because 9X is multiplying 9 times X. But what we really need to be doing is adding those two things together. So the 9 and the X add together to make a binomial, which cannot be simplified, of X plus 9. Again, X plus 9 is not the same thing as 9X. We needed to add those two pieces together, not multiply them. And what we have right here, guys, is the expression we were looking for. The outside portion, which is 9, times the whole thing, which is X plus 9. And if we do that on the secant segment, that product is equal to the same concept now on this piece right over here. Well, it's a little bit weird to talk about, but let's do it. That's a tangent segment. So the outside portion of your tangent segment, the part that's outside of the circle, is 15. You multiply that by the whole thing. Well, since this tangent segment is entirely outside of the circle, it doesn't have an interior component the way that the X did. So the whole piece is 15 as well. So we end up multiplying 15 times 15. And I believe that's why in our notes we ended up writing that as the tangent segment squared. You're just multiplying it by itself. Okay, so that's our expression, or our equation, everybody. Outside portion times the whole thing is equal to outside portion times the whole thing, or in this one case, times itself. Let's see what we can do to solve here. Most of us are going to distribute here and get a 9x plus an 81 is equal to, and 15 squared is going to get us 225. We're going to subtract an 81 from both sides. Those 81s cancel, and that'll leave us now with a 9x is equal to, and that is going to be a 144 there on the right. We would divide both sides by 9 and end up with an answer here of x is equal to 16. That's 144 divided by 9. So number 5 is a trickier problem than what we did in number 1. The equation is a little bit tougher to set up, but let's keep practicing that on 6 and 7 and 8, and hopefully we'll get the hang of those pretty quickly. And the last problem I wanted to do with you, number 9, is really the same concept as number 5, but it's a different presentation. The most important thing here to recognize is that the point of intersection between your two lines, just like in number 5, is once again outside of the circle. That means that it's the same concept we just discussed. It's the outside portion of your tangent or secant multiplied by the whole thing. And if you can do that for each one of the two line segments, you're going to get two products that are equal to each other. So let's focus on the top, everybody, the one that goes from here to here. Outside portion times the whole thing. Well, the outside portion, what's outside of the circle, is 7. So we start with that. And we multiply that by the whole segment that I've highlighted there in yellow, which is the sum of 7 and x plus 3. So if I ask you to add the 7 plus the x plus 3, the 7 and the 3 get put together, and we end up with an x plus 10. And if you're not sure where that came from, that was actually 7 plus the x plus 3. Okay, so that is outside portion times the whole thing for the top segment. And that product is equal to, and now we're going to do the exact same thing down here on the bottom. The outside portion times the whole thing, but now we're talking about this piece right down here. Okay, so down in the bottom, how long is the outside portion? That's your 6 there. So the outside portion is 6, and that gets multiplied by the entire bottom segment, which is 6 added to x plus 7. And that is going to get us an x plus 13. And again, some people like to write that out. We got that by adding together the outside portion, 6, plus the inside portion, which is x plus 7. And when we combine like terms, we end up with the x plus 13. Okay, so I'm going to move, ooh, not that. I'm going to move this out of the way a little. I'm going to move this out of the way a little. And now what we have to do, everybody, is some distributive property here to get rid of the parentheses on both the left and on the right. So let's work on that. All right, on the left, we're going to distribute the 7 in. 7 times x is 7x. 7 times 10 is going to get us 70. On the right side, 6 times x is 6x, and 6 times 13 is going to get us 78. Okay, I like to move the smaller x to the bigger one, so we're going to subtract a 6x from both sides. At the same time, we'll subtract the 70 from both the left and the right. And what happens? 70s cancel on the left, 6x's cancel on the right. 7x minus 6x just gets us 1x, and we don't need to write the 1 there. And that equals 78 minus 70, which is 8. And that, everybody, is the solution we were expecting here for the value of x. 10, 11, and 12 work in a similar manner to number 9. So, as I said before, both 12.4 Part 1 and 12.4 Part 2 are very difficult sections with a lot of different ideas going on. So, make sure that you have good notes written out with the formulas next to you. Work through those problems, check your answers, and let me know if you have any questions, guys. Good luck!